Hi everybody. Have you ever wondered why is this debate happening now? I mean, the automobile industry in Europe is trying to water down the phase out of the combustion engine, even though this is planned for 2035, so it's still 10 years ahead. And at the same time, countries like Norway, they already have about 90% EVs for new cars sold, and China is already at 50%. So why is this debate happening now? Do they know something we don't know? Let's find out. Welcome back to Climate Change Calculated. My name is Gerald Schuler. Today about EV adoption around the world, modeling with the S-curve, or the power of modeling. So we have to answer these three questions. How can we predict and estimate the coming years? How can we judge the current situation? And which signals matter and which are just noise? So we need a method that is simple, transparent, and based on data, not wishful thinking. So how do we do the modeling? So technologies or technology adoption is usually following an S-curve. And that is true for past transitions like the transition from horses to cars, from analog to digital photography, from simple mobile phones to smartphones. The adoption follows a characteristic S-shaped curve. And this S-curve is a surprisingly powerful yet simple model with only a few parameters, which is important for fitting them to data. So the first is the growth rate. How fast is the adoption happening? Then the final saturation level. Where do we end up? And then the tipping point in time, when do we have the quickest change? Policies and politics can influence all of those parameters, as we will see. So here you can see how a basic S-curve looks like. So it starts slowly with a slow start, where we have an exponential growth. Then we have an inflection point, or a tipping point, where we have the fastest growth. And then finally we reach a saturation. And here in this curve we have a percentage, because percentages are better to compare different countries. So this model is basically a very simple formula, a so-called logistic function. And the three parameters are the L, the saturation, the maximum share that we can reach, then K, the growth speed, and T0 is the inflection year when we have the tipping point. So for modeling, we just need to determine these parameters such that the curve fits the observed data points. And then basically we can extrapolate and also see where this curve tends to head and where it goes. So by fitting the data, we can change the parameters for the curve such that it can be early or late with the T0. Then we can have a slow or fast growth with the parameter K. And we can also have less than 100% saturation with L. So we just need to try out those three parameters and see how they best fit the observed data. Yeah, and the data we have mostly from our World in Data, which you can see in this link here. And also more sources are available in our description and in our GitHub that you can see here. And all plots that you will see are generated from CSV files, comma-separated variables, generated or downloaded from the website, and code linked to the description. And this code was Python code, and that was written with the help of our climate change assistant. So that's actually quite a good help, and you can see the link to it here, and it's also available on this QR code. So you can use it yourself and try it out and also ask it questions. For instance, you can ask anytime for background questions that you may have. Yeah, so the data that we have combines plug-in hybrid and battery electric vehicles. Yeah, and then when we do the modeling, we find those points don't perfectly match an S-curve. There's always some deviation. So we need to add uncertainty bands. So the data can fit more or less to an S-curve. So this is also connected to a certain uncertainty band. And that is done with a so-called bootstrap resampling. That means we fit to subsets, random subsets of those points. And then we get many different possible models. And we take the most common 68% as uncertainty bands. So that corresponds to the so-called standard deviation, plus minus the standard deviation. So that gives a nice statistical model, which also includes the uncertainty that we have in our model. And it turns out this uncertainty is actually quite an important part of this modeling process, because then we can see in what range the future will probably be. Yeah, so here's an example for Norway, this S-curve. So the orange dots are the data points for the different years that we have. And then we can see the blue line is the S-curve, which is the median of all the possible models, so in the middle. And then you can see this blue band, which shows the uncertainty between the different outcomes. So in the video, you can see how different possible S-curves appear. And you can also see that some models appear outside this blue band. And that is because it's possible, but this blue band shows the most common 68%. So the 68% which lie in the middle. So this gives us the most likely outcome, or this band shows the most likely models. And in the plot you can also see the found parameters for the median for this country. For instance, here the L is 9, K would be 0.49 per year. And also keep in mind this K is the constant for the entire curve. So no matter where we are on this curve, at which point in time, this K is a constant of the shape of this curve. So keep that in mind. And also here we can make points where we have 20% market share, 50% and 80% as milestones. Yeah, another interesting example is China. China is right about now at just over 50% market share. And you can see that uncertainty band is becoming quite wide after the present time. So after 2025, it becomes quite wide. And that's kind of an interesting observation, which means that we have all sorts of possible outcomes. So with the current trend, we can go into saturation, a bit above 50%, like 60%, but we can also reach 100% around 2030. So 100% EV share for new sold cars in 2030 in China is quite possible. So now we can compare the different S-curves for different regions of the world or different countries. So here the blue one is Norway, which we just saw. So it's already at almost 100%. Then the green one is China. And China is right now at about a tipping point, and it can reach easily 100%, but it can also be getting stuck depending on policies. Then we have the United States in red, which is right now kind of low, but we can see the uncertainty grows a lot. So with the current policies, we have a lot of uncertainty. So it can easily be that they reach a very high percentage of new cars being EVs in 2035. So they become quite close to 100%. But interestingly, the European Union is different. When you look at the orange curve here, you can see it goes to saturation around 50%. And also the uncertainty band doesn't increase. So based on the current trend, it seems Europe is heading towards early saturation around 50%. And that's probably because when you look at the data points here, they kind of flattened recently. And that's probably because of the end of the incentives that we had like in a few years ago and in 2023. Sales went down, and basically that is a bad trend. So that means that probably new incentives are needed to get the adoption going again. Yeah, so this is something that those uncertainty bands can easily tell you. And this is probably also what the European auto industry is worried about, that the current trend is basically heading towards an early saturation, which contradicts the goal of 100% EVs in 2035. And it also shows that they're not confident having new incentives making it possible. Yeah, so for the 2035 goal of 100% EV, new cars sold, we can see Norway is almost there. China has a good chance of reaching this goal. Even the US has a realistic chance of reaching this goal based on the current data because of the big uncertainty. But Europe appears to be approaching 50% saturation, which means it will be difficult to achieve this goal and new policy measures will be necessary. Hence the attempt by the European automotive industry to water down this target. Yeah, so when you look at the S-curve for Germany and the influence of policies, you can see here this blue curve. Here you can see the uncertainty band, and it looks pretty much like the European curve, probably because Europe is dominated by the German market. And you can see here the orange dots are the data points, and you can see how it starts to fall down after 2022. And this is caused by the rebate reduction plan. So all of a sudden, the rebates for new EVs was cut down. And that led to a reduction of new EVs being sold. And this is reflected in those points. So you can see that this rebate reduction had a big influence in the adoption. Previous ones were actually accelerating it, like CO2 fleet emissions rules, and here first the environmental bonus increase, so where they actually had this rebate coming in, so that actually had a big effect, and the same as removing this rebate had also a big effect. So that also shows that those policies have a big influence in shaping this S-curve. Yeah, and here in this table or plot you can see when those different policies start to come and which ones for which countries. And you can see the earliest one here on farthest left here is Norway. So they had a very early start in the 1990s and going on until today. So they had quite a stringent and consistent policy for increasing EV adoption, and it worked. Then the second earliest was China, as you can see here. So they also had this new energy vehicle policy, which started in the 2000s, and it also then led to the earlier adoption than in the rest of the world. So actually government policies helped. Then you can see here, green was the next from the EU, European Union, and the US came kind of late. You can see here, and the US is in orange here up here. So also the S-curve came kind of late. So that kind of fits. It shows that policies play an important role to spur the adoption of new technologies. Yeah, and in this plot, you can also see interesting positions of different countries with respect to the percentage of new cars sold on the horizontal axis and the growth rate K. Remember, K was constant for a given curve. It shows basically how fast the adoption is happening. And here you see a few outliers. So here on top, you can see China. China has a very fast growth, but they are behind Norway because they are just above 50% new cars EV, but they're catching up fast. So you can see Norway is already far ahead at over 90% new cars being EV. And they have a good K rate. So it's fairly fast adoption, but say not much faster than the United Kingdom. They just started later. Then here you have Germany and the EU, very similar positions. So they are at around 20% new cars sold being EVs. And they have kind of this kind of on low end adoption rate. So the K factor here is not very high. So the speed of adoption is not so high. And then here on the far left, you have the United States. So the speed is even slower. And also the percentage here is around 10%. It's also much lower. So that's also why there's more uncertainty for the US. Yeah, and here you can see a map of the adoption of EVs across the world. And here again, you can see that Norway and Sweden and Finland are kind of far ahead with EV adoption, so Scandinavian and Northern Europe. And also China is far ahead of the rest. Then Australia, India, Europe, the Americas, they're kind of in the middle. Yeah, so what are the takeaways? Many countries are entering the steep part of the S-curve, and falling EV costs and better charging push adoption faster. So that's part of the incentives for buying EVs. And then we also saw that uncertainty is explicit with our uncertainty bands. So it's important that we also compute and show the confidence bands also to see the possible outcomes in the future. So that means data beats opinions. Yeah, so conclusions. The S-curve allows us to estimate the current development dynamics and extrapolate them into the future with uncertainty bands. Political measures influence the start, the speed of the dynamics, and the saturation at the end. And the current S-curve indicates insufficient saturation, suggesting that supportive policy measures are needed, like purchase incentives, legal concessions, combustion engine phase out, infrastructure, and so on. Yeah, and then call for action. Try your own country. We have the code and data in the description. And comment what you think, who is next. And subscribe and like our channel for more reproducible calculations. Yeah, thank you for your attention and see you next time. Bye bye.